we'd really ever do with bar magnet stuff is what I call a Lenz's law application of, well, a Lenz's law application. I think that's what maybe you're getting at.
Yeah.
So, for example, let's say that we have, this is the front of this loop of wire, and this is the back of that loop of wire. And then we take some bar magnet like this, and we drop it through that loop. Is that what you're talking about?
Yeah.
That sort of problem? Good. So we want to know if we drop, when this thing is falling through this loop, or as it approaches the loop, probably, what's the direction of the current, the induced current in that resistor? Good kind of question.
Yeah.
So first thing we have to do is talk about what's the first thing we have to do? Talk about what? Yes, the field that's made by the bar magnet. So what do magnetic field lines around bar magnets look like? They point away from north and toward south. So we'll say that the field looks like this. And these things, of course, curl all the way back around here. But there's a field that, yeah, I just made it uglier, that does that. Okay? So right now, what we do is, what I would say is we sort of think about what's the flux situation here, right? I would say, I'll even do this, that if we extend these, wait, I just did extend those. They go out like that. These ones come out like this. This one comes straight down. This one comes out like that. We groupage these. So there's, what I say is there's, I don't know, maybe there's some amount of flux made by field lines that point downward, right? Or what I say is there's some downward flux. When we do this, now there's more flux in that enclosed loop made by field lines that point down, or there's more downward flux. Right? Flux is not a vector. It's not really true to say downward flux or inward flux, but it's a sort of a shortened way to think about it. So there is now, well, an increase in downward flux. So Lenz's law says, what? Why?
Maintain constant flux.
What maintains constant flux? Flux. What maintains constant flux? What about the loop? The induced current. So induced currents, I'll say, are in a direction, that attempts to maintain constant flux. Now, what if this will be online? Well, it's okay. You write it down. Now, so we have small downward flux. Now there's more downward flux. So the loop tries to make more upward flux. Therefore, we put our thumb upward. Our fingers wrap in the direction of the current that made that field. And that means that the current in this resistor goes that way.
And then when it falls through,
Yes.
it goes the other way?
Yes. All right, so when should I draw it? So when this thing is up here, this field now does this. Right, we can extend these, extend that, and then group, how's this going to work? Group this stuff. Yeah, sure, with this stuff. Sure. Groupy group. Yeah, good. So as this thing falls down through, there's some flux from field that points down, or some downward flux. Now there's less downward flux. So we want to make more downward flux. We put our thumb downward. We wrap our fingers around it in the front. The current now goes that way. if the question said, what's the direction of electron flow in that resistor, then sure, go left-handed.
Okay.
Yeah. But if it says, what's the direction of current, they mean conventional current. Conventional current being the direction of the positive charge flow for that oscillator. In a conductor, at least. Good for Lenz's law or more than Lenz's law? Yeah.
Just a quick question.
What?
Does
Okay.
it switch from current going this way to current going this way at the half of like the magnet?
There's some point where, I'll just do this, where the flux doesn't change in here, right? So it's like, right here there's, flux there's field lines that are doing that, and at some point, there's just not any change, or that change is very small. Yeah, so it goes from being, sorry, that's not going to move. It goes from being one way to stopping to the other way. Yeah. Okay. Good. And I'm guessing that graph, I don't want to say anything stupid, but yeah, I don't know what that. If we do current as a function of time, it's small and then probably gets big. It probably does that. I guess. What else? Should I stop this one?
Can we hold?
Sure.